Is this website visible? TinkerCAD?
Yes, sir.
Okay, fine. So this is a you. If you have time, you kindly make a note that website ID is www.tinkercad.com. TINKERCAD.com. So what you have to do is it's an open source free version. So you the ultimate aim is you have to create an account. The first step is you have to click join now. After clicking join now, it asks for a educator or student join a class something. You create your own account. So you have to click create a personal account. After clicking this, you will be prompted with the option like sign up with the email or sign in with the Google. So the our my preference is always use your Gmail account to sign in, because you don't have to make a note of password in each and everything. So you click sign in with Google. It will be prompted with your user credential like your details, your Gmail username and password. You put your password and the email ID over there, and this account will be created. And after that, you can click sign in to prompt it that. So this is the only thing you have to do. You have to click join in, and after that, you have to click create personal account. And after that, by using the Google, you just create an account. After the successful creation, it will be prompted with another thing like a signing. Okay. So once everything is over, will be prompted with a new window like signing. Okay. As I have an account already, I click here the button sign in. I click my sign in with my Google account. So as I already said, it's asked for the account what I'm going to use. I click my account, my Gmail account, which I have used for creating that TinkerCAD. So after clicking that, if my account is been already available, this screen will be available, and which I have showed you in the PPT. Is this screen visible?
Yes, sir. It's visible, sir.
Okay. Here you can see two options. For example, in general, it will be in the 3D design model. I think this is the first option, 3D design. If you click this, what will happen is you can prepare your 3D design modeling. But we are not going to work with 3D design. We are going to work with circuits. So you have to click circuit. As soon as you click your circuit, you will be prompted with a new option like create a new circuit. See, you have to click your button circuit, and after clicking that circuit, you will be getting a new option like create a new circuit. You have to click this, create a new circuit. As soon as you click it out, you will be prompted with the second window, which I have shown you in the PPT. This is the actual working screen where you are going to work. Okay. Here, what you have to do is the topmost one is your here incredible Ambris, some name is there. What I'm going to do is I'm going to do a LED control. Okay. I'm going to give an LED control, means this LED control, this everything is connected to the cloud platform, and whatever the changes you make in this window will be automatically saved to a cloud window. There is no need that you have to save it out. So whatever you do, that will be saved automatically in the cloud window. You don't have to worry about that. The only thing you have to do is you have to give the project name, and that or what thing you are going to work. You just click it over there and give a name. So whenever you go back and come to your account, that project will be listed. That will be easily accessed to you. And also whenever you okay with that your project and you like to any collaboration with your friends, you can click this share button, which is available in the last. You can, I think the pointer is above the share button. You click the share button and send to your friend. Your friend also can make some modification, and also he can work it out. So these are the easy option which is available. So what I'm going to do is I'm going to control an LED, which I have said you earlier. For that, what I have said is I need an Arduino controller. If you need, you can type it over here, or you can see what are the availability of parts is there. I think here you can see Arduino R3, which I have shown you. Here you just click that code only once, and this will be along with your mouse. This is your workspace. It will be available over here. Again you click once, that will be done. pasted. Okay. So the first thing is your Arduino Uno board. You have to, if sir, I like to search. Search means you type Arduino. Here you see the first one is Arduino. Like that you can search also. That is based upon your thing. You first I need an Arduino board, so I have given an Arduino board. Then I need a breadboard. Because the breadboard will be so useful for connectivity purpose, so I have taken a breadboard, clicked over there, and I have pasted over there. And after that, I have said that I need a LED. I'm going to control an LED. So I have clicked an LED and I have pasted over here. And I said that I need a resistor because the ultimate goal of the resistor is to protect. Without resistor, I will show you the output. And after that, I will show with resistor because this is an simulation. If anything happens, it's that. Okay. So I have given a resistor. As I said while discussing in the topic, I'm connecting that positive part to the fifth pin and action needed. And my goal is I have to make that LED on for 5 seconds, and I have to make that LED on for 5 seconds and off for 12 seconds. That is the goal which I have given. So just here you can see that code option. You click the code. In here you can see three options: block text. Is that visible? Block text. Is that visible?
Yes, sir, visible.
Okay. You just click text option. It asks for continuous because it will be having a default level of program over there. So as soon as I click text will be chosen and the program will be shown here. See here, as I already said, there are only two functions. One is setup function and another one is your loop function. In the setup function, you have to say what are the things that should be assigned for the pin. As I already said, I'm going to use my fifth pin. Here you can see I have connected that pin to my digital pin 5. So I'm saying that pin mode fifth pin, that is an output pin. So I have declared output. So whenever I'm running this program on the controller knows, okay, our master has given that he is going to use the fifth pin as an output pin. So it is not an input pin, it is an output pin. So you can just send that value out from a microcontroller to the external device. So after that, as I already said, delay are in microseconds, milliseconds. 1000 milliseconds is nothing but in 1 second. So every 1000 is calculated as one. So digital write, first thing in the loop, high. What pin I have assigned in the setup? Fifth pin. So my fifth pin is high. How many minutes? How many seconds? 5 seconds. So 5000. So 5000 millisecond is equal to 5 seconds. So it will be okay. Again, digital write. After that, what should happen is 5 seconds. It should be low second low. So how many seconds it should be off is 12 seconds. So 12,000 milliseconds. So in the first setup file, I have given that I'm going to use my fifth pin as an output pin. In the loop, I have given this, that is my fifth pin should be high for 5 seconds and it should be low for 12 seconds. So whenever I run this program, this LED will be on for 5 seconds and off for 12 seconds. So this is the simple code. Once that is done, you click start simulation. Whether this output is visible to you? After 12 you can 15 so 12 plus 5 17. Here you can see the time. After 17 it will be glowing on. At 22 it will be off. At again at 34 it will be on. Again at 39 it will be off. Is that okay? Is that okay, pa? Everyone? Is that okay? You have any doubts? If you have any doubts, you can ask me, because this is the basic setup. So in the setup file, what you will be doing is you will be giving the pin which you are going to use, and the loop you will be giving what it that specific pin must do, that you will be giving in your loop function. Okay. So for another thing, as I already said, you play and see. For example, what I'm going to do is I'm going to make this as 10 seconds and off for 5 seconds. So now you take it out. This LED will be on for 10 seconds, and if this LED will be off for 5 seconds. You can watch the timer here. Whenever I start the simulation, you can watch the timer here. Here you can see. Here you can see, like 1, 2, 3, 4, 5. Here you can see the light is glowing on. After 10 seconds, it will be off. So next it will be waiting for 5 seconds. So 10 plus 5, 15. In the 15th second, it will be again on. Okay. So I think you can see a warning button here. That is the main. That is the only thing, because I am providing the current which is above that LED light. For that, what I have to do is I have to limit that value. For that, I have to use a resistor. So I am connecting my resistor with the ground. Okay. So this resistor's one end is connected to the LED, and my resistor value is 220 ohm. For that, you should use your formula like Ohm's law. V is equal to IR. My voltage is 5 volt, and my resistance is 220 ohm. You can measure the current. The current will be less than 20 milliamps, so it won't affect that light. So again, I am running. I have not changed the program. I have changed only the hardware connection. Again, I am running the program. Now you can see that here there is no warning symbol. Is that okay? Is that easy? Whether it's easy, pa, or you find any difficulty? Can I continue? Okay. Hari Prasad, okay. Can I continue?
Yes, sir.
Okay, okay, fine. Thank you. Here, right now, what I'm going to do is I'm going to take an RGB LED. RGB LED, in the sense, it has 4 leads. I have connected that 4 leads. I'm removing this LED connections. Right now, what I'm going to do is, I think while keeping the mouse on the pin, it shows the first one is red, second one is cathode. Cathode is nothing but ground, and third one is blue, and the fourth one is green. If you likely to control this LED, you have to connect. For example, I'm connecting that green LED in my third pin, and I'm connecting the blue LED in my fourth pin. I'm connecting my red LED in my fifth pin, and my ground pin to the resistor ground. Simple thing, simple connection. So this single LED, which has three colors, one is red color, another one is blue color, and green color. What I'm going to do is I'm going to control 3 pins. So based upon that program, that the LED colors are going to change. Okay. So again, I'm going to click the code, and I'm going to copy this code for 3 times, because I'm going to use 3 pins. So the first pin is third pin, second pin is fourth pin, and the third pin is fifth pin. For example, to my knowledge, I'm making a command line. What color is this? First one is in green color, second one is in blue color. These dummy lines won't be executed, or they are known as a command line. That is for only code level checking. Okay, and the last one is red color. So I have defined, I have said to my controller that I'm going to use 3 pins. One is third pin, fourth pin, and another one is fifth pin. All the 3 pins are output pins. So my third pin is connected to the green light, fourth pin is connected to the blue light, and my fifth pin is connected to the red light. So I just copy this program. I have reduced the time to 1 second. Okay, I have reduced this time to 1 second. I have copied it 3 times. Here you can check. First thing what I'm going to do is I'm going to make my green LED glow. So third LED high for 1 second and again third LED low for 1 second. So as soon as my green LED on and off, my blue LED should on. So my fourth pin should be high and fourth pin should be low. As soon as my blue LED on and off, my red LED should on. So my fifth pin is high, fifth pin is low. So simple program. So for this light will be on and off for every 1 second. So that RGB LED is going to emit green color for 1 second, blue color for 1 second, and red color for 1 second. For every mutual 1 second, it will be in off condition. So I'll be starting the simulation. Now you can check the output. See, first one green, then blue, then red. How about this one? Is there any complication in coding? Is there any complexity in coding, or it's so easy to do that? Anyone? Is that okay? Can I continue?
Yes, sir.
Okay, fine. Right. So this is for an RGB LED. So like this, you can control. Sir, I like to change the time, sir. My first LED green should be on for 2 seconds. We can give 2 seconds on, 1 second itself off. My third LED should be on for 3 seconds, sir. So on time alone 3 seconds. Off time is 1 second. My last LED, red LED, should be on for 4 seconds, sir. So it should be on for 4 seconds and it should be off for 1 second. So whenever you run this flow, your green LED will be on for 2 seconds and it will be off for 1 second. Then your blue LED will be on for 3 seconds and will be off for 1 second. And your red LED will be on for 4 seconds and will be off for 1 second. I start the simulation. Here you can check the output. See, 2 seconds for green LED, 3 seconds for blue LED, and 4 seconds for your red LED. Okay. Okay then. So this is all about the thing. So which I have already said, we are going to use multiple tags. In the tags, pin mode is used for declaring the pins, the purpose, either it is input or output, that has to be declared. And digital write is used for only writing that value from the controller to any external value. That is done by the digital write pin. And your next pin is your delay. So your delay is used to control the time difference between your one execution to the another execution. You can give, but these functions are readily available. Just we are calling that function and we are providing that value. The task has been completed. Okay. If that is okay, can I move on to next one?
Yes, sir.
Okay. So as for our topic, again, I will be sharing it in your chat window. So these are the topics which we are likely to discuss right now. So first we have discussed about Arduino and what is the basics of robotics. And after that, right now we have discussed about LED. That is, we have controlled a single LED and a group of LED. Sir, I should use only the RGB LED. Can I use some other? Yeah, you can use. You can use the same single LED 3 times and you connect all the LEDs and the same thing will happen. For example, I'm just stopping this LED, and I'm collecting the basic LED connection. Okay, this LED should be connected for 3 times. 1, 2, 3. Same connection should be given. So I'm giving my third pin here, fourth pin here, and fifth pin here. And for a resistor, one ground from here, one ground from here, one ground from here. I'm not changing the program. I just run that simulation. See, first LED is on, off, then second LED is on for 3 seconds and off. Then the third LED is on for 4 seconds and it is off. You can change the color also. When you pick this LED, it's asked for color. I can select yellow color. I can select some orange color or some green color, red color, and I can select some. After clicking that, it will be asking for color, blue color. Okay. Now, if I start simulation, the colors will be varied. First one is yellow, and next one is red, and third one is blue. Okay, the code is same, but the connection is different. So you have to know the basic connection skill, and if you connect that, you will be getting that output. Is that okay? Okay. Okay. I'm moving on to the next topic. That is nothing but controlling your switches, and another one is potentiometer. Switches in the sense, now the task is running. Whenever I give some input, without giving the input, I have given a program to the controller. Whenever the controller is on, this task will run. Sir, what is the task? The first LED should be on, and after the second LED, and after the third LED. Now, what I'm going to do is, whenever I press a switch, this thing should be happen. That is the task I'm going to do. Switch means what kind of operation, sir? I'm going to take a push button. I'm placing a push button over here. Okay. I'm taking a push button. This push button, you have to think, whenever I'm pressing that button, what will happen is this LED what we have earlier mentioned, this LED will be on, and after that this LED will be on, and after that this will be on. This will be done only when I press the switch. That is the concept which we are going to do right now. Okay, here you can see that whenever I'm keeping a mouse here, terminal 1S, this is a terminal 1 pin, and this is the terminal 2nd pin. These 2 pins are internally connected, and here you can see that terminal 2A and here 2B. These 2 pins are internally connected. So these 2 pins, whenever I give some ground here, this can be taken from here. Whenever I connect any 5 volt here, this can be connected from here. So they are not, this pin and this pin, they are not connected to each other. Whenever I press the switch, these 4 pins are shorted. They are connected to each other. That is the logic here, and based upon that, we are going to work here. So what I'm going to do is, I'm taking an ground connection. So one end is connected to the ground, and another end is connected to the digital read option. Okay, second pin. So see here, one end I'm connecting to the ground, and another end I'm connecting to the digital pin. So another side I'm connecting to the 5 volt pin. Another side I'm connecting to the 5 volt pin. This is the small connection. See, as I already said, my second pin will be always connected to this. This pin is connected here. As this side is connected to the ground, always my second pin will be reading 0. Whenever I press this switch, what happens? This all the 4 sockets are short circuited. So this 5 volt will flow through this pin, and it will reach the second pin. That is the concept. So based upon that concept, I'm going to just change the code alone. I'm going to add another one, that is for reading that switch pin mode. I have connected that pin to the second pin. So second pin is my input pin. Input is nothing but from where that input is taken. So from here that value will be read by this controller. Here what I have to do is I have initiate another two more lines. Int my button. I have declared an variable like a button. It is an integer value. I'm going to read that value, digital value, digital digital read of my pin number is 2. So as soon as this loop is open, my second pin is will be read and it will be stored in the button. Okay. If I will be checking if my button equal to high, high or low is based upon the user input. If it is high, this process will happen. If it is low, else what will happen is nothing will happen. Okay. So you check it over the, I have just remodified the code. I have not done anything. Just I have added another condition. Like you check it over the switch button. One end is connected to the ground. Here you can see the terminal is connected to the ground. That ground is connected here. So this side is internally connected to this end always. So this ground will flow from here to here. So always without pressing the switch, my ground is connected to the two. Ground is nothing but low. And the another end I have connected a 5-volt pin. So whenever I press this switch, this all the 4 pins are short circular, and this 5-volt will flow through here to the second pin. And automatically what it happens is the high level is initiated. Whenever the high level is initiated, this task will be done. After completing this task, again it checks for the button. Okay, this is the coding. I will start the simulation. You can check the output. Check here. All the LEDs are in the off state. When you are comparing with your previous program, you can see that whenever I start the simulation, automatically that program, that LED started on, but it waits because you have given in your program that that second pin should be high. Whenever that value high is attained, this task will be done. Okay. So here you see, I press that switch once. See, first LED is on, then second LED, then third LED. Once this task is completed, again it waits. It does not do any other task. It waits. So again what I should do? I should click that button. One time if I click the button, it will be doing the task. If I press n number at a time also, it will be finishing the task, then only it will be doing the task again. Okay, this is the concept of switch. In the switch, what I have used is I have used an digital read. So as I'm going to read here, I have given this pin as an input pin. Are you clear? Are you okay with that? Any doubts in a switch? Okay. There are 28 more students on this session. Only few are replying. At least, can I expect a reply from all the students? Okay. Hari Prasad, Harigaran, Angeline, Jeevan, Snega, okay, Dhanushya, Yogeshwar, Hema, Prasanna, yes, sir. Okay. Okay, fine. Arjun Satish. Okay, yeah, nice of you all. Thank you. So, okay, again in our chat window, what I have already given my syllabus. Next, after switch, I'm going to discuss about potentiometer. Right? The potentiometer, in the sense, what a potentiometer is nothing but a analog variation. For example, as I said, the AC will be continuously cooling the room. So we have to monitor the coolness regularly. So for that, what I will be doing that is we will be using an analog kind of sensor like temperature sensor, and we'll be monitoring the temperature in a continuous fashion. So whenever the room temperature attains that value, the compressor will be switched off. That is the concept. Here we are going to detect that only thing which we are going to use. I'm removing all the things which I have used earlier. Okay. I need one LED. Okay. I remove everything, and after that I will be adding it. Okay. 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 I need an LED. So I place an LED, and after that I need a resistor. I put a resistor, and ground is connected to the resistor, and resistors one end is connected to the thing, and another end is connected to that another thing. So this I will be connecting in my next program. So what I'm going to do is I'm going to take a potentiometer. Potentiometer is nothing but an variable resistor where you're going to change your resistor. Here you can see this is a fixed resistor. For example, now its value is 1 kilo ohm. If I like to change for 220 ohm, I have to click there and enter the value. Now it's 220 ohm. It's a fixed value. If you like to change your value in a continuous fashion from 0 to, for example, if you click this potentiometer, it shows the value like 250. I'm selecting a value like 10 kilo ohm. Now what it does is it changes the value from 0 ohm to 10 kilo ohm. That is the thing. You can use this slider and you can change the value. You can read that value also. That is the thing which we are going to do. Removing this sensor and placing some other analog sensor means we can read that value that we will be seeing in the upcoming time. Here, first one is terminal, second one is wiper, third one is terminal. So terminal 1 and 2 can be used as VCC ground. As resistor though does not have polarity, you can connect anywhere. Okay, so I'm connecting one end to the ground 5 volt and another end to the, in order to provide it neat, I'm connecting it one end to the ground, another end to the 5 volt. Okay, so whenever I changes the resistance value, there will be some drop. I'm going to read the drop by using my analog sensor. I can use any of these analog sensors. If you go with some other sensor, you can choose A0, A1, A2, A3, A4, A5. It's upon your wish. I am using A0 as an pin. Okay, so this is being connected. It is ready. So one side is 5 volt and another side is ground. Whenever I change the value here, the difference will be flowed to this value, and that will be noted in the A0. And by using this A0 port, I can read that value. Okay, right. Now the coding part is to be done. Here, what I'm going to do is I am going to serially monitor that value. Okay, 1 minute. I will be changing the just changing the board's position in order to get that value noted. Everything is in drag and drop, so no problem. The connections won't be interconnected. Okay, and now it's visible, right? So here what I'm going to do is I'm going to monitor that value in a serial monitor. As I said, it is an analog to digital converter. Analog means continuous varying value into a digital value. This controller, microcontroller, support 10-bit ADC. 10-bit ADC in the sense 2 power 10, 1024. When you start from 0, the value will receive is 1023. So whenever you change this potentiometer value, that value will be changed from 0, starting from 0 to 1023. So whenever you change to some other sensors, so each and every sensor will provide this difference. So you have to note the difference and you have to make some decision on that. So that is the thing which we are going to do right now. What I'm going to do is I'm going to take that value. First, that my value is changing between 0 to 1023. So I have given serial dot begin 9600. This 9600 is nothing but the default baud rate. That is the number of bits transmitted per second. I'm going to transmit a maximum of 9600 bits, so I have given. So when you are using any high speed devices, you can change that value. In default, you use 9600. Here what I'm going to do is, I'm going to read that value in some sensor, right? Some sensor value. Here I'm going to analog read. Last time I have read the digital value. Here I'm going to read the analog value. My pin is A0. I have defined that. Last time what I have mentioned is, I have mentioned then digital read. So the digital value is assigned. Here I'm going to read the analog value. So A0 is assigned. So this A0 value is saved in the sensor. Okay. So after that, what I have to do is, I am going to check that value, because I have to know. No, you will be physically changing that value in the potentiometer, but we have to monitor that. So I am serially printing that value in my computer itself. Serial dot print. There is a difference between print and print line. Print means it will be printing in a continuous fashion. Print line means one by one. So I'm using print line, this sensor value. Okay. So if you need delay, you can delay. I'm giving a small delay of 0.1 second. If you need, you give, else you delays don't want. Okay. This is a simple program. So whenever I change this value, I can monitor the value over here. I am starting the simulation. Here at the bottom of the screen, I think serial monitor, one thing is visible. You click on that. I think the value is visible. Okay, what is the value over there, ma? What is the value that is been printed in the serial monitor? Yeah, Snega Ramamurthy, it's 0. Okay, yeah, it's 0. So right now what I'm going to do is, I'm going to change this knob. See, I'm going to change this knob. First position is 143. My next position is around 300. My third position is around 500. My fourth position, it's around 670. My fifth position is around 800. And my next position is 1000. And my final value is 1023. Did you all check? My value varies between 0 to 1023. Is that okay? So what happens whenever I change that value moves from 0 to 1023. So by making that potentiometer varying, we can note down that value. Is that okay? Can I, by right now, what I am going to do is, I know when changing this potentiometer, its value moves from 0 to 1023. What I'm going to do right now is, I am having a threshold value. For example, I'm giving as a 500. Whenever my potentiometer value is above 500, the LED which I connected there should be in on condition. Whenever it is less than 500, the light should be off. This is an user controlled one. So whenever the value of potentiometer is greater than 5, the LED will be on. If it is less than that, the LED will be off. Can we try that? Can we try that? Yeah. Yeah, Yogeshwar. Nice. So here, see, I'm stopping that simulation. Just I'm going to take two more changes, because I have to connect this LED. I just think I'm going to connect this LED with 8th pin. Okay. What means, I have to declare the pin of LED. My pin is 8th pin, which is an output pin. Okay. And after that, what I have to do is, I have to check that sensor value. If my sensor value is greater than 500, what it has to do means, it has to digitally write digital write my digital write my 8th pin high. If not means else what you should do, you should off that light. So digital right 8th pin low. Here I'm not giving any delay, because as soon as you change that difference should take place. Here see, I'm starting that simulation. Here see, my value is 1023, so my LED is on. Now I am reducing my value. Now see, 859 LED is on. Now see, 696 my LED is on. Now see, it's around 511 my LED is on. Now see, 491 my LED is off. We can make a fine tune also, but it's not so perfect. It's too low. Okay, it's around 491 my LED is off. My value is 491. Whenever I'm changing this position, see, whenever it's above 500 my LED is on. Is that okay? Now what we have done, we have just used an analog value, that is an external. You think is an AC, the temperature sensor. I will be removing the temperature sensor, and I will be adding an temperature. I will be removing the potentiometer and adding a temperature sensor. Automatically, when that temperature reaches, that outer compressor can be on or off. So in a real-time application, the working process will be like this. Is this okay? Can we move on to next one? Okay, Snega, yes. Dhanushya, Ariprasad, Janani, Yogeshwar. Yeah, fine. No. Okay, nice. Okay, so our next topic. Our next topic is our next tag. We can say that right now what we have done is we have analogically read a value and we have checked it out. Now what we are going to do is we are going to write the value. So as I already said, ADC is an ADC controller which is available in Arduino Uno is a 10-bit controller. So what we have done is we have made an 10-bit value. So we have given 2 power 10, so 1024. So from 0 it's 1023. Whenever you convert a value from digital to analog, then it is the port available is an 8-bit port. So it is an 8-bit pin. So 2 power 8 is 256. So whenever you are writing some value, you can write the utmost value of 256. Whenever you start from 0, it's 255. So here the same program, I'm going to make only a small change. Right? Here, everything is okay.
Sir?
Yeah,
The last one we did, sir. I'm having a doubt, sir.
yeah.
Can we make it between a range of resistance, for example, between 500 to 600? The
Yeah,
output must be.
yeah.
How
What you have
can
to
you do
do,
that, sir?
yeah, what you have to do is you have to add a thing like and. If it is, it should be greater than 500 and my sensor value should be less than 600.
Okay.
So what it happens is it checks the value, it is above 500 and also it should be less than 600.
600.
So my LED will be on between these two values are on. So you can start that program. Here my value is now 532, my LED is glowing on. It is below 500, my LED is off. When it is above 600, my LED will be again off.
Yeah, okay, sir.
Now it's okay?
Okay, sir. Thank you, sir.
Okay, thank you. Okay. Okay, our next program. Next program, what we are going to do is we are going to analogically write a some value. As I already said, in these 13 pins, you can use only 3, 5, 6, 9, 10, 11 to analogically write some value. So they are called the PWM pins. Okay. So what I'm going to do is I can't control an LED in the 8th pin. So this connection is wrong when we are going for analog, right? So I am deleting that wire. Okay. Okay, I have deleted that wire. Now what I'm going to do is I have to connect. I can connect either in 11, 10, 9, 6, 5 or 3. I can use any of these 6 pins. So right now I'm using my third pin. Okay, keep it that I'm using my third pin. So go for the code. Here, whatever I pin I mentioned here, that I have to intimate that. So I have mentioned as third pin as my output pin. So I am again reading that analog value. You know that whenever I am reading that analog value, that value switches from zeros to 1023. So what I have done for just for a okay, I changed the complete code. Okay, first you understand the program, then we can go for this analog. Okay, here what I'm going to do is I'm going to use a for loop. For int I is equal to 0, I less than 255. As I already said, it should be less than 256. That is 255 I plus plus. Okay, for loop. Then I'm opening the bracket, then closing the bracket, and I'm writing my analog write off. Pin number is third pin I have choose. That value is that goes on should be increasing. Then only I can see the difference. So I. So for demo purpose, I am using a delay function, delay of 500. In order to check it out, I am printing that value in my serial monitor, serial.print. So what is the thing happening that I should know? So I am printing that I value in the serial monitor. Now what it do is the program started, the computer connection is serial begin is started. Again I'm going to use my third pin as an output pin. I have written a for loop, so the for loop will be executed till my value ranges between 0 to 255. So from 0, 1, 2, 3, 4 it goes till 255, less than 256, that is 255. Again when it reaches 256 it will be stopped, and again that value will be become 0. So what I'm doing is I'm analogically writing that value in the third pin, that pin value, that is 0 or 1 or 2 or 255, that value will be posted here, so that this brightness will be varied. Because in digital pin you can see the variation as 0 or 1, that is it may be low, on or off, but here you can see the brightness is controlled. For that only we are using these PWM pins. So we can monitor the value in the serial monitor. I have given a serial print line of same I value. So for what I value, what is the output I am getting there? To monitor that I have given here. So right now you can see this thing. See, for 0, 1, 2, 3. See, the delay is too much high. I am reducing the delay to some 100. Okay. Okay. Right now you can see the difference. See, the brightness of the LED has been increasing and decreasing. Okay. As soon as it reaches 245, again it moves on to 0, off. Okay. In order to understand further so clearly, what I'm doing is I'm again copying that loop, and again I'm pasting that loop. Now what I'm going to do is the first loop increases from 0 to 255. The second loop, it decreases from 255 to 0. Should be less than, should be greater than or equal to 0. So I minus minus. So what happens is from 0 to 255, slowly the light will be glowing on, and again as soon as this loop is completed, we will be moving on to this loop. In this loop, that value will be moving from high value, that is from 255 to 0. It goes on decreasing. So that is easily monitored in your output. Again I am running that value. Now you check. Now the light will be slowly glowing on. So my value is around 100, 150. It goes on. So once it reaches 255, it against decrement, the brightness of the LED will be reducing. See, the value is getting decreased, the brightness is also getting decreased. Once it reaches off condition, again it will be increasing. Do everyone okay with this concept? Everyone okay? Can I continue? Yes. Yes, Sigeshwar. Fine. Yes. See, okay. In order to make it so clear, I am adding another product. Like just I am connecting an DC motor. Okay. See, I am taking a DC motor. DC motor positive end is connected to the negative end connected to the negative edge, positive end connected to the same LED. Now you can see the dual output here. One is the LED brightness and the thing. Here the speed of DC motor is controlled. That is we will be saying it in RPM, revolution per minute. So whenever the voltage is high, it will be fastly running. Whenever the voltage is low, it will be slow in running. Now check it out. See. You can see the monitor serial monitor value here. For 255, it reaches around 2000 RPM. Again, it gets decreased. See. Okay. Okay, I have stopped it. Angeline Sweetie, I can't understand serial begin function. Would you please explain that again? Okay. Okay, no problem. The serial begin is nothing but used to connect your system, right? So this is the only tag. Whenever I give serial begin 9600, your board, that is your Arduino Uno board, is connected with your computer in this port, that is at baud rate of 9600. So your system will be sending information in this baud rate. So whatever things you have to see here, if I'm not using the serial begin, for example, the same result is there. I'm just dummying this line. I'm starting the simulation. Now you can't check your output in here. See, this will be increased. You can't see any value here because you did not say the system that I'm going to start an communication. So first thing, what you have to make sure your board is communicating with the system. So I am saying that serial begin of 9600. So 9600 bits can be transmitted per second up to 9600. So no problem with that. So I have mentioned that. So right now I'm beginning this. I'm removing that dummy line. Now check. See, I am initiated that system. Now my board is connected to the system. By using this serial tag, serial begin, serial print line, I am printing that value, whatever. So that printer value will be noted here. This serial monitor is nothing but a communication between both the computer. This serial print will print the value, whatever you say here. For example, you see, I am saying as a project contest. Okay, and I'm playing. Now what happens is the project contest will be printed here till 250 times, 255 times. So this serial.print line is nothing but the statement which sends the data to that thing. That is the only thing you have to make it there. Okay. Angeline, is that okay?
So is that specifically we have to give 9,600?
Yes, ma, because that is the basic requirement of 9600. When you are going for any high speed devices, that baud rate varies. Actually, there is a multiple n number of baud rates. For example, 9600, in the multiples of 9600, 17,000, 20,000, 30,000, till 3 lakhs bits we can transmit per second. So there is n number of bits. So in order to understand in a simple way and for a basic level of communication, 9600 baud rate is quite enough.
Yes, sir. Understood, sir. Thank you,
Okay,
sir.
thank you. And Janani Budalingam, you have asked about, sir, could you explain the analog write function? Yeah, sure, ma. Analog write is nothing but, it is not, I will be typing here, ADC is an 10-bit one, DAC is an 8-bit. Okay. So what is mean by 10-bit and 8-bit? For example, 1011011011. This is an 10-bit information. Whenever you are sending that value, it will be like this. So each and every bit will have a weight. So it will be in the option like 2 power 0, 2 power 1, 2 power 2, 2 power 3. So when you combine all this value, the final decimal value will be in 1023. So the information when you are sending with analog to digital, it will be sent in this fashion, 10-bit. Whenever you are sending an information from ADC, it will be in 8-bit information, that is 10110111. Here only 8-bit will be transmitted. Okay. So this 8-bit means the maximum value of this 8-bit is 255. That is 2 power 8 is 255. So that only I have said that the value will be 255. What you have to do is this in analog write function, you can write that analog value. That analog value varies from 0 to 255 alone. So whenever you change in the intermediate value, for example, in digital, you can't make any intermediate value. For example, the LED may be either on or off. These are the two conditions which takes place. But in analog write function, what you can do is you can take the intermediate value. Intermediate value in the sense it may be high or any intermediate. For example, it may be 1 or it may be 0.8, it may be 0.7, it may be 0.1, it may be of any kind of value. But in the digital rate, it cannot be. It can be 0 or 1. This is the one possibility in digital rate. So in any applications or some other thing, if you need to control something in an intermediate value, then you have to go for analog write function. Is that okay, Janani Budalingam? Okay. Okay. Thank you. Thank you. So our next one is an ultrasonic sensor. What we are going to do is these are the tags. I think I have completed all tags like pin mode, digital read, digital write, analog write, serial begin, serial print, delay. So which I have mentioned earlier. So these are the 8 tags. When you have a complete knowledge about these 8 tags, so whenever you are surfing over internet for multiple programs in respect to Arduino, these are the tags which will be usually available. So that will be quite easy for you. So only thing you have to know is what is the purpose of each and every tags, that you have to clearly know about that and you have to work on with that. Okay. Is that okay? Fine. Next, I'm going to deal with an ultrasonic sensor. Ultrasonic sensor is nothing but a distance measurement sensor. So in order to check any distance, we'll be using the ultrasonic sensor. So based upon that ultrasonic sensor, we can measure the distance, and also we can control any applications like LED control or some other thing we can do. So right now we can use an ultrasonic sensor. You type ultrasonic sensor, see, you will be getting an ultrasonic distance sensor, like sorry, ultrasonic. Yeah, here the ultrasonic sensor is there. You can take that sensor and you can work it out. So for a time being, what I'm going to do is I have removed all the thing. Okay, I have typed ultrasonic, and in the search window there are three things, which is already there is an connection oriented board is there. I'm clicking that board and just pasting in my workspace. Okay, and I am taking my sensor over here and changing my rotation direction. Okay, now what I'm going to do is, whenever here there are two blocks, one block, the first circle is the transmitter block and second circle is the receiver block. How it works is, it emits the sound waves. One is transmitter and another is receiver. That circle is, one is transmitter circle and another is receiver circle. One emits the signal and another one receives the signal. So it emitted and receives. Once it receives, the distance is calculated and distance is printed. That is the minimum level of operation over here. Here you click the code, again text mode. Here it is, as it's a default program, they have given the thing. I will be explaining each and everything. Okay, you have to, don't worry about that. This is the most minimum level of code. Okay. What I have done is, I'm going to just calculate the distance in which a object is there, which I have already mentioned. An object avoidance robot and all other robot, everything will be working on this principle. One will be transmitted and another one will be received. So based upon the receiver, we can easily calculate the distance. Based upon that distance, you can make anything. For example, if you are moving to some door, it detects the object, automatically the door should be open. You take any smart dustbin, if you are going near the dustbin, automatically the ultrasonic sensor detects the object. Automatically the dustbin lid will open and you can put your garbage there. And once you move away from the distance, that is a threshold limit, that lid will be closed. So like this, there are many automated systems are there available with this ultrasonic sensor. Here you can check it out. Here there are two pins. Actually, here they have mentioned only signal pin. In the real-time product, there are two pins. One is trigger pin and another one is echo pin. Trigger pin is nothing but you will be generating the signal, and echo pin will be after it touches any objects and it gets reflected. No, that is the echo pin. So whenever the signal transmitted and received, that will be received by the echo pin. So here, as for now, they have given only one pin. So you are going to emit that signal in that same pin, and you are going to get that value in the same pin. Here you can see, I have mentioned that pin mode, my trigger pin output. My trigger pin is nothing but I have intimated here the two pins that in the real ultrasonic distance function. So whatever I give here, that will be my pin value. Here in the program you can see that I have given 7,7. So my trigger pin is 7 and my echo pin is 7. So that value will be transferred here. So my pin mode, 7th pin is output, digital write, 7th pin low. It waits for 2 microseconds and again it makes that pin high. So it's like a square waveform. So again that value will be for 10 microseconds. Again that pin will be low. So the same pin will be high, low, high, low, high, low. That pin will be touches that object and will be received. As I already said, the same pin is used. Here I am using the same pin, echo pin. Echo pin 7th pin is input. That value is being read and that pulse is calculated. That pulse is being calculated and it is multiplied with the 0.0173. That is nothing but the pulse to centimeter conversion. That converted value is returned back from this loop. So once it returned back, that is been received here, and that will be placed in the centimeter. So that centimeter is being printed in the serial monitor. You can check that centimeter value, and based upon that centimeter value, you can make any decision or control some LED or do some other thing. Okay. So see here, right now I'm playing my thing. See, right now it shows like my distance is 113 centimeter. Here you can see. Okay. Now I'm moving the object. See, it's 82 centimeter, 75 centimeter. So it should be in that range. I think V-shaped structure you can see. Okay. I can. A V-shaped structure you can see. You can move this ball in any of this. See, the maximum value is 299 centimeter. Here it's 300. Again, when you go here, it's around 200. So you can move. Whenever I move out of this distance, there won't be any reflection. So automatically what it happens is the signal will be lost. So if the signal is lost, your value will be above 330. So we can declare that your ultrasonic signal has been lost. So whenever it's in this limit, it detects and it says the value. Okay. Now what I'm going to do is, I know that value is saved in the centimeter. So I'm going to write a loop. For example, going to switch on a light. Light. For example, my centimeter is greater than 150. Again, what it happens is my digital write. Any one pin. My third pin should be high. Okay. I'm not putting any else condition. So from this, you know that whenever my centimeter value is above 150, LED will be on. In all other conditions, my LED will be off. So if you need else condition, you can put else. My LED will be off. So whatever you are declaring here, you have to say it in the pin mode, setup mode. So pin mode 3 as an output pin. Same program, nothing changed, but here I have to add the product like LED. Okay, I have to add an LED. Okay, LED, and one is the resistor. That's it. So one end is connected to resistor. Resistor one end is connected to ground. LED one end is connected to the third pin. So now, right now I'm starting the simulation. You can check the value. See, it is 130 centimeter. So my LED is off. So I'm changing that value. I'm changing the value to 160. Now see, you can see this LED on. Above 150, my LED is on. Below 150, my LED is off. So in the same manner, if you connect this with any what I can say, DC motors or some other thing, you can control the obstacle avoidance robot. The robot right direction or left direction, you can control over that, and you can do it over that. For example, I can also say now, right now we have done a small project in this students distance maintenance. So in their ID card, they can have this ultrasonic sensor that is being connected with a board. So it repeatedly checks for the distance. Anyone is coming in the distance range of 6 meters inside the school, automatically that ultrasonic sensor will make that buzzer to beep. So it is noted that someone is near. So automatically the distance should be maintained. It is a small mini project that has been done by one of the students. So it is an idea. So the idea matters. So the applications and all other things that can be easily done, but your idea should be most reliable and also most pitching to any one point. So right now COVID is there. If you do any project related to COVID or helping to COVID situation, that will be an perfect one. So you think like that and you can make it done. Okay. Is everyone okay with ultrasonic sensor? I will post this codes. Actually, this code is already available in the default program. If you need, I will, after the end of the session, I will be posting this code in your WhatsApp group. If you connect this thing, and you also can check the output. Okay. Okay, ma. Okay. Fine. Our next, okay, let me stop the simulation. Let me move to my next topic, like servo motor control, right? How to control a servo motor? So what is the use of a servo motor? See, as far as a DC motor or some other thing is concerned, they will be rotating always. For example, whenever you give 5 volt, before two experiments also you can see, whenever you're controlling that voltage, the speed RPM is being increased or decreased, but that DC motor is not in the off condition. It is increasing or it is decreasing. But whenever we are having some task or having some project that should be controlling something, then we need servo motors. See, in servo motor, what is the advantageous thing is we can precisely control the angle. For example, my motor should be in a 0 degree, or my motor should be in a 45 degree or 35 degree or some other degree, like that. In general, you can specify any degree of thing over there. So based upon the degree of motion, you can do. For example, you take any ATM machine, you are giving your card and you are giving your ATM pin. As soon as you are given your pin, what happens is the amount is being counted and the door is open. The door is open for a particular angle alone. Whenever you remove the cash from that, the door automatically closes. It does not rotate for any 360 degree or some other thing. It opened or closed for only 45 degree or 50 degree. So like this, any angle rotation is needed, then you have to go for servo motors, right? There are many servo motors are there. So what I'm going to do is I'm going to take a small servo motor. So I am just typing a servo. Before that, I am removing the old project. Okay, here in your search window, I am typing servo. Here, if you like to individually connect each and every product, you can just click and connect over there. As far as the time is so low, as only 20 minutes are there, I'm taking the thing which is already connected. Okay, I'm clicking here and I am connecting over here. Okay, this servo motor which you see is an 90G servo 90G motor, which we can control only 180 degrees and not 360 degrees. So this 180-degree rotation can be controlled to any angle. For example, you can keep it in 0 degree, 10 degree, 20 degree, 40 degree, but you can control only till 180 degree. That is the only option you can see it over here. So all the connection is made. Here the red color wire, here you can see power is connected to the 5 volt, ground is connected to the ground pin, and this is the signal pin which is connected to the 9th pin. Okay. As far the code is concerned, these are the dummy lines. I am reviewing all the lines for your readability and for your here you see what I'm going to do is I'm going to initialize a servo motor. Here you see I'm saying that I'm going to use an servo file, so I'm including this servo files is inbuiltly available in this TinkerCAD, so I have been adding that. In Arduino IDE also this servo.h is available, so I have intimated that. Then I'm creating an tag for that servo. I'm attaching, that is servo I have been created. This servo is being attached with that code in the pin number 9. If you need this minimum and this is the minimum and maximum rotation value. If you need, you can use, else you can attach the pin alone. So I have attached my pin 9th pin. What I am doing is again my if loop int, sorry, for loop int I is equal to 0. my I should be less than or equal to 180. My I value should be incremented I plus plus. Okay, now what this program do is it varies the value from 0 to 180 degree, and its attached value, it will be writing that value in this value is I, and it waits for every 150 milliseconds, that is 0.05 seconds will be waiting and will be printing. Now you can see that the servo motor will be rotating in one direction. See, from 0th position to 180 position, it will be moving. Is that okay? If sir, it has to move in the forward direction and also in reverse direction. Again, for loop int I is equal to 0, I is equal to 180, I should be greater than or equal to 0, I minus minus. Now I am writing that value. So what it does is it moves on from 0 to 180 and again from 180 to 0. Can you see it? Can you see that rotation? So in order to understand, I have given that, sir, I have to see that angle also means, again, serial dot begin 9600. Your serial port has been begin. Here you can write a serial dot print line of I. So you can monitor the value in parallel. Okay, here also I'm adding the tag value. I'm starting the simulation. I'm opening the serial monitor. You see the angle and also see the bottommost value. So once it reaches that 180 degree angle, again it rotates back. Is that okay? So like that you can monitor the value and also you can control it over there. Is this okay? Yes. Okay. Okay. Fine. So what I'm going to do right now is, this is for a complete set of values. Right now what we are going to do is, we are going to have any fixed values. Okay. Fixed value in the sense, any angle. See, I'm going to first fix it at 180 means 30 we can divide. First 30 degree, then I'm giving delay for 1000 seconds. After that I'm giving another 30 degree. I'm adding another 30 degree means it should be in the angle of 60 degree. Then 90. Then 120. 150. Then 180. Last time what we have done is we have continuously varied the value and change. Now we have given that angle alone. So based upon that angle, for every 1 second that should move. See, first, second, 90, 150, 180. And now again, it goes to initial position. 30, light, 90, 120, 150, 180. Like that again and again it will be rotating that. Like that you can see the angled rotation also. Fixed value also you can give. I have given every 30. You can give 90 or 45 and you can check it out. Okay. 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 Can I move on to next topic? Next topic is nothing but DC control, which I have already have. I will be showing that to you. This is the thing which I have already taken. What I have done is I have taken that 5 volt and connected to the plus button. If I connected this plus button, all these pins are connected to 5 volt. And again, I taken a ground button connected to minus. All these pins are connected to the ground. And again, from this plus to this plus, I connected. So these pins are connected to plus volt, and this ground to this ground. All the pins are connected to ground. I have taken a L293 driver boarder. The working process of an L293, this driver board, is to drive the current, because whenever you drive any high power devices like DC motor, some other thing, the board cannot provide that much of current in order to run that motors. So in order to that, what we will be doing is we will be using the external power. But right now it is an just introduction class. I have not used any external power. I have used the, see here, power tool is connected to 5 volt. Here see, the power one is connected to 5 volt. So I am using that Arduino 5 volt result to in order to check that output. After you are connecting with any hardware device, you can connect any external battery or adapter and you can provide voltage. So based upon that voltage, the speed of motor can be controlled. Here for I am giving around the 5 volt. See, this power is connected to 5 volt. This power is connected to 5 volt. And I am going to control these two pins. When this pin positive and negative are connected to positive and negative, they will be rotating the forward direction. If it is connected in the reverse direction, that is negative to positive and positive to negative, this motor will be running in the reverse direction. So what I have done is I have added a switch in order to control the forward direction and backward direction. In one side, it will be when I place it will be moving the forward direction. If I place it in the another direction, it will be moving in the reverse direction. See in the code, I have mentioned this. This button is one side is connected to the positive and another side is connected to the negative. This button name is a slider switch. So the centermost pin is connected to the 13th pin, which I am mentioning here. Okay, 13th pin as my input pin. And after that, I am using an enable pin. That is, I am not using an enable pin. That is okay. Fourth pin is connected to the input pin. Here you can see that as an input pin. So my here from this value it is going here. So this is my fourth pin and this is my seventh pin. This is my fourth pin, this is my seventh pin, this is my fourth pin, and this is my seventh pin, and this my button is on 13th pin. Okay, now what it does is my fourth and seventh will be controlling the speed, the polarity, that is whether that should be run in the forward direction or backward direction. And here is, you see, the 13th pin I'm checking. So in default it will be connected to the lowest. If I keeping the slider switch here, it is connected to the ground. If I keep the slider switch here, it is connected to the high volt. So normally I have given it as a low condition. So if it is normally connected to the low, so it moves in the forward direction. Whenever I move the slider to this side, it is connected to the high value. So this loop won't execute and this loop will be working. So I have changed the polarity, see, high low to low high. So automatically motor will be rotating in the reverse direction. Here you can see. See, the motor is rotating in the reverse direction because I have kept the slider switch here. Okay, if I'm moving it to another side, see, it is moving in the forward direction. If I change this position to backward, again it is moving in the backward direction. Again, if I click positive, it will be moving in the forward direction. So like that, you can control any DC motors by making any switch or some other thing you can add and you can control. You people, I have added this TinkerCAD project in a chat window. If you people like to work with this, this is not available here. If you like to work with this, you click on this project file. The same thing I'll be sharing it in your project context website also for DC interfacing. You can check that value. Okay, like that you can control your DC motor. That's so simple. If plus and minus are connected in a correct way, motor will be in forward direction. If plus or minus are invertedly connected, the motor will be rotating on the reverse direction. So based upon this concept only, you are providing, that is low high and high low. So this condition is controlled by a switch, so that you have to activate that switch. So based upon that, the whole operation can be controlled. Is that okay? Is that okay, Pa? Yes, okay. So for your reference, again I have shared the thing which I have promised you to teach. That is first we have teach I have teached about Arduino and robotics, and next I have taught you about how to control LED, single LED and multiple LED with the RGB. Then we have interfaced buttons and we have checked with the output. Next, we have added a potentiometer and we varied that value from 0 to 1023, and also we have controlled an LED. If it is below or above, that based upon that condition, we have controlled an LED. And after that, by using the analog write function, we have controlled the PWM pin like brightness control. In that also, we have connected a DC motor and we have checked with the pin. And after that, we have added an ultrasonic sensor. The main thing is whenever the object comes in that limit, the rays fall on that object and be reverted back, and that will be received by the echo pin, and that will be said. If there is no object is detected, then there will be no value, that will be above always 500, 330. If any object is there, then automatically the signal which you sent is retransmitted back, and automatically that will be some variation in the signal, and you will be getting that thing. This we have checked it out, and this we have checked with a small LED. Whenever an object is detected, LED is on, and whenever there is no object, LED is off. We have checked with that. And after that, we have discussed the DC interfacing motor that you can see in the display itself. If you control the button, the DC motor will be controlled in the forward direction and the backward direction. And after that, we have seen about a servo motor. In the servo motor, it is an angled rotation. See, DC motor is not an angled rotation; it is a continuous rotation. Wherever you need any angled rotation, then you have to go for stepper motor and servo motors. So servo motors, you can incline to a particular angle from 0 to 45, 90, 180, something like that. But a stepper motor, you can go by step. So there is a difference between stepper motor and servo motor. Here we have seen a stepper motor, servo motor with various angles. That also we have seen here. And after that, we have seen last topic is project discussion. A small example project which I likely to share with you, like our hand movement. See, there are many humanoid robots available right now. So each and every humanoid robots has their fingers control. So here what we are going to do is we are going to control a servo motors by inclining that position. So first thing, I'm going to use here. This is a single finger control. So after that, we can see a multiple finger control. This is a single finger control. This is a servo motor which you already seen. 5-volt ground and signal pin to some other pin. What you need, you can connect. And I'm using a flex sensor. Based upon the inclination, reduction and movement, the flex sensor value will be varied. I'm detecting that value in my analog sensor. So here you can see in the code, see, I am attaching a servo motor and also a flex pin. That flex pin is noted. That flex pin position, that minimum position is 770 and maximum position is 950. But this servo motor angle is 0 to 180. So what I am doing is, when the value is between 770 and 950, this value is converted to 0 to 180 degree. So that is done by the map function. That is the actual thing. So that servo position value is changed to 0 to 180 degree. That 180 degree is moved to position. That position is returned to a servo motor, and you can see. Okay, here you can see that servo motor position. See, now it's the normal position. So the servo motor is not changing. It's in the same position. Now see, I'm going to change that inclination position. If I increase, the value will be changed. If I decrease, the value will be decreased. Whether you can see this? Can you see this? If so, can you chat? You can put in the chat window. Can you see this? The movement? Yes, sir. Yeah, yeah. The same thing. In spite of a flex sensor, you just keep your finger. You can take a centermost finger, some other finger. You will be moving. That moving will be controlled. What I am doing here is that movement. So if I move that finger, the corresponding servo motor's angle will be changed, and based upon that, that corresponding value will be moved. That is the thing which happens. Okay. This is a single finger. Okay. Right now I'm moving to a multiple finger. I'm showing 5 fingers. So 5 fingers means you need 5 servo motor, 5 flex sensors. I'm sharing that thing to you. Okay. Okay. Here you can see I'm having 5 fingers right now. The 5 fingers are connected to 5 different sensors and 5 different motors are there. I'm starting the simulation. Whenever I'm controlling each and every flex sensor, each and one individual motors will be controlled. See, I'm controlling the first one. The first one is controlled. Okay, when I'm increasing, it goes on increasing. Okay, now I am controlling the second one. Okay, now I am controlling the third one. Now I am controlling the fourth one. I am controlling the fifth one. I am controlling the first one. I am increasing the third one. I am increasing the fourth one. I think each and every motion can be controlled. This is the thing which happen. As far as this is concerned, there is a small delay in the circuit. So in real time, what it happens is whenever there is a movement, it automatically switches. That is the speed of operation will be quite speed. So you can see the output in a perfect way. So here are some delays are there. So that will be rectified when you are going to a hardware design. So like this, you can have your fingers controlled like that. You can control any of the fingers. When you connect these servo motors to something like a hand movement, virtual hand, you can control your things. Okay, but you need these flex sensors in order to check it out. You need these flex sensors, but as far as the flex sensor is concerned, it's around 400 to 500. So for this 5 thing, you have to spend around 2000 to 5000. For that only, like this TinkerCAD, they have provided a free version, so we can check the output. If everything is okay, we can after that purchase that thing and we can connect it out. Okay, right. And my last thing is an as per the thing is home automation. Everyone okay with this finger? I have shared it in your Google chat window and also in your WhatsApp account. So after the class is over, you can sign in on your account and you can check the motion. This belongs to Ediylabs thing, so no problem with that. You can make your own tinkering with that. The code is also available on that. Okay. Okay. My last one is home automation. So this is an small example for home automation. So in an busy one, I have connected that. So there will be something. For example, I have connected an ultrasonic sensor, which is a distance measurement, PIR sensor to detect any object is coming there. So based upon this motors, one for servo motor and another for servo motor for one sensor ultrasonic and another for here. To control this DC motor, we need a driver board, and we can also monitor the temperature. These are the things which happens. In the code, you can see. See, whenever my PI sensor is high, my fourth pin is thing is controlled. My fourth pin is nothing but here. Okay, my fourth pin is nothing but this LED. So whenever my PI sensor is high, my LED is controlled. I'm starting the simulation. See, see. Here, see the LEDs. Every LED is getting blown up. When it is in the range, that is in the specific range, I think you can see LED is glowing. Okay, if it is in the range, that LED will be blown. And another thing for ultrasonic sensor, if it is in the thing, it is so close, you can see the servo motor is changing. So for example, as I already said, if some person is entering, automatically the door should be open. We can connect a servo motor and do. If any person is detected, you need some alert sound is there. So you can have this sensor to do that alert rotation. So automatically, in spite of LED, you can connect any buzzers or some other thing to do that. And another thing, we have a temperature sensor. The ultimate goal of temperature sensor is to monitor the temperature. Here, I am keeping a temperature as some below value. Here, by controlling that, you can control this DC motor. See, whenever the temperature is too low, my motor fan is off. Here, you check it out. My fan is off. Whenever my temperature is somewhat high, motor is running. Whenever it is too high, it is running in a faster fashion. So it goes on increasing and decreasing. Whenever there is no temperature at all, automatically my stepper motor, my DC motor will be off. So the PIM motion will control the LED, the ultrasonic sensor will control the servo motor, and the temperature sensor will control the DC. So I am connected the three different applications in a single board. Okay. So in a home automation, you think whenever you are in a home, whenever you are entering a home, what happens? First, the ultrasonic sensor detects, okay, the person has come. So automatically the gate will be open. So I have used the servo motor. So automatically the servo motor will open. So in that range, if you come, the servo motor will ping and it will be saying that some person is coming and it will be opening that. And after that, what will happen? This PA sensor, it will be detecting the people. If you enter the home, it automatically detects and it will be switching on the LEDs or lights which is available on your home. For example, if you enter, you mentioned that two rooms or two halls should be on. The hall and room LED will hall and room lights will be blown on. And whenever you go and sit in the shoba in the hall and you think the temperature is too high, you can't you are not in a mood to go and off the fan, the temperature sensor will do that. You go and sit on the shoba, the temperature will automatically detect the room temperature, and if it is too low, then the temperature will be that is motor will be running on a high speed. If it is too low, that is the fan is not required, then it will be in off condition. So that you also, I think I have shown that when it is high, that is low, the outside temperature is too high, it will be running in a fast fashion. When it is too low, then the fan will be off. Like that, we have detected these two sensor also. Whenever the person is coming inside, the door will open and the door will close. Okay, when he move out, the door will be again closed. Whenever the person is entering somewhere, the LED, all the lights will be on, and once a particular time period, it will be off. Okay. So as of now, this is the thing.